Okay, this is mechanics, chapter 2 and 3 course division. Uh, okay, try and get it under 1 hour, بس يلا. Quizzes are more important than course division, but still solve them. Huh? The diagram below shows the projectile motion followed by a cannon. Graph roughly the horizontal displacement and the vertical displacement time. These graphs, you must know them, okay? أكيد. The horizontal displacement, of course, it's increasing at a constant rate because you have velocity is constant. But the vertical displacement, it's accelerating. So will it be a straight line for the displacement or will it be curved? Obviously, it's going to be curved because it's accelerating. You guys know if there's acceleration, the displacement will be curved. Okay? So if there's a constant velocity, no acceleration, the displacement will be a straight line. Graph roughly the variation of the horizontal and vertical components of the shell's velocity with time. Assume upwards is a positive direction. I remember this was question 1 of the week. Is a highly 9 of the week 7 mechanics quiz. I remember this question and it came copy paste in the exam. So, variation of the horizontal and vertical components of the shell's velocity. Okay, the horizontal velocity, guys, it stays constant. But since your acceleration in projectile motion is negative 9.8, so okay, the velocity will be decreasing for the y component. There's the x component, which remains constant, and the y component, which goes down, right? How does the magnitude of the acceleration of the shell vary with time? Okay, I actually want to see this. Okay, the magnitude of the acceleration does not vary with time, which remains constant and equal to minus 9.8. So, in projectile motion, A is equal to negative G, which is minus 9.8. Okay? طيب, a cannonball is launched, it always comes, at 37 degrees with the initial speed of 25. Calculate the greatest height. The maximum height is equal to V naught squared sine squared theta over 2G. So it's going to be 25 squared sine 37 squared over 2 times 9.8. 25 squared sine 37 over 2 times 9.8. 11.5. Yeah. Calculate the smallest speed of the ball as it moves through the air. Always the smallest speed is at the maximum height. At the maximum height, the velocity is equal to just Vx, which is equal to V naught cosine theta. Okay, this is always a rule for projectile motion. So V naught cosine theta, so it's going to be 25 cosine 37. So it should be 20. Yeah. Calculate the range of the ball. The range is equal to V naught squared sine 2 theta over G. Okay, so you're going to get 25 squared sine 2 times 37 over G 9.8. 61.3. Oh, 0.2. Give you a 0.2. I don't know, it's probably a mistake in the question. Question 3. Compare the ranges of a projectile shot with the same initial speed at 30 degrees, 50 degrees, 70 degrees. Okay. Range is equal to same formula I just used. V naught squared sine 2 theta over G. As you increase theta, as theta approaches, look, as theta approaches 45, theta approaches 45 degrees, the range approaches the highest range. Because when theta is 45 degrees, you get the highest range. Why? Because sine of 2 times 45 is equal to 1. Okay, because it's sine 90, which is 1. It's like, let's say theta was like, I don't know, 15. If it was like theta is equal to 15, sine 2 times 15 would be 0.5. And what's easier to multiply by 1 or by 0.5? Obviously by 1. 1 will get you a bigger answer, right? So, as you get closer to 45, you're gonna have a larger sine 2 theta. You're gonna have, it will be a higher range. How do you compare them? Here's what you do. Take your calculator, you get sine 2 times 30. 0.86. Okay, take it here. Then you go sine 2 times 50. 0.99 or 0.98. sine 2 times 70, 0.64. Which one's the highest value? 50 degrees. So that means the highest range is 50 degrees. Second highest is at 30 degrees. The least highest is at 70 degrees. Yeah, so they did 2 times. They got these values. So that means this is what we got here. Okay. A rock is launched from the ground at 10 meters per second at an angle of 53 degrees with the horizontal. Take t equals 10. Calculate the time the rock is airborne. Time total is equal to 2 v node sine theta over g. So it's going to be 10 sine 53 over 10. I think the 10 will just cancel. You get 2 sine 53. 1.6. Okay, that's already up, bro. Okay, 1.6, yeah. The horizontal distance, let me just put this here. The horizontal distance the rock travels and the maximum height. Okay, الأول شيء let's find the horizontal distance. يعني بدهم الرينج. والرينج is equal to v naught squared sine 2 theta over g. So it's gonna be 10 squared sine 2 times 53 over 10. Just put this in our calculator. 10 squared sine 2 times 3 over 10. You got 9.6. 9.6. Okay. Height. What's height equal to? Height is equal to v naught squared sine squared theta over 2g. So 10 squared sine 53 squared over 20. So you got, let me see. Just change this to 53 squared over 20. 3.2. Yeah. Okay. Assuming the initial speed of the rock remains the same, at what angle with the horizontal should the rock be launched to achieve maximum height, longest time airborne, maximum range? Always maximum height. I told you for maximum height, maximum range. Theta is equal. Wait, no. For maximum height. Okay, let me show you. The equation for maximum height is this, right? Here, right? Which one would get you the best? Always know that sine 90 is equal to 1. This is, I want to have 90 degrees. This is the best case scenario. For range to have 90 degrees, 2 times theta should be equal to 90. So akid, for range, the best case would be when theta is equal to 45. How about for height? Height, it's sine squared theta. So you could just say sine theta squared is equal to 90. We can cancel the square and square. You're just going to get theta is equal to 90 because sine theta is equal to 1. Sine theta squared is equal to 1. Square with both sides, you get 1. You're going to get sine theta is equal to 1. So theta is equal to shift sine 1, which is 90. I'm just trying to prove it to you. So, for the maximum height, the best case scenario is theta is equal to 90. And for the maximum range, the best case scenario is theta is equal to 45 degrees. How about the longest time airborne? Time is v node, 2v node sine theta over g. Again here, whenever you just sine something, the best case scenario is when that theta is equal to 90. So again, for total time, the best case is theta equals 90 degrees. Let's see, 90, 90, 45. 90, 90, 45. Okay. A motorboat is moving in a river 6 meter per second due north. The river is flowing at 2 meters per second due east. What's the speed of the motorboat relative to a stationary? Okay, this always comes. إذا هو رايح 6 due north. Okay, هو رايح 6 north. Okay, the river is going like this. 2 meters per second east. What's the speed of the motorboat relative to a stationary observer on the shore? So highlight was 6 meters per second. Let's call this J. You added 2I, so you have 2I plus 6J. That's his velocity now, right? طيب, how much is the speed going to be? Just the magnitude of that. 2 squared plus 6 squared. I'm just going to show you the solution. Okay. Yeah, there you go. 6.3. Question 6. A person in a motorboat wishes to cross. This one. Okay. Wishes to cross a wide river along the shortest path from A to B, as shown in the diagram below. The boat can sail at 5 meters per second in still water. The speed of the water is 2, and the distance from A to B is 500 meters. Calculate the angle alpha at which the person must direct the boat to get to B. So, here to get to B, we want to end here, okay? They give us, this is the velocity he has, right? This is the velocity of the river, right? And then this is, I don't know, let's call this is the resultant. Because he wants to go horizontally without going up, without going down. He wants to have his fine position here. Type, okay, we have this angle alpha. We have a right triangle, obviously, right? We have the opposite side, which is 2, because it's a river. And we have the hypotenuse. So sine opposite of hypotenuse. Opposite over hypotenuse. So shift sine, sorry. So sine alpha is going to be equal to the opposite 2 over the hypotenuse 5. So akid alpha will just be shift sine 2 over 5. You get 23.6. Okay. For part B, they're saying determine the time taken by the boat to cross the river. We need to know now, akid, the time is just going to be equal to the distance divided by the speed, because speed is distance over time. Anytime you want time and you have the distance, we just need to divide by the speed. If you use 5, akid, you're going to be wrong. Now, what is the velocity we're going with? If you use 5, that's if there's no flow of river pushing you up, right? But here there's flow of river pushing me up. فأكيد I'm gonna have some like change in the velocity. ما حتكون 5 exactly. حيكون فيها ال 2 pushing me up. We're gonna have this resultant velocity that we drew up here, VR. Why VR? Because I want to end up at B, so we want it to be straight. طيب, VR, that's my velocity. How do I find it? Okay, you can easily do it like this. You have the angle here, 23.6. The way they did it in the solution is different. You have this angle, 23.6. You have the hypotenuse. VR is the adjacent. Cosine of the angle is equal to adjacent over hypotenuse. So just multiply. We want the adjacent side, right? So just be the adjacent side will be cosine the angle times the hypotenuse. So 5 times cosine 23.6 we found in the part A. You do this and you get this. This is your speed. Now divide the distance by the speed. So 500 divided by this, you get 109. So it's going to be 109 seconds. Okay, at 12 p.m. on, it's the closest approach. Okay, at 12 p.m. the position vector of ship A with respect to an origin O is 3i, and that of B is 2i minus 1j. A moves with a constant velocity, this, and B moves with a constant velocity, this. At what time are the ships close to each other? Okay, look here. Closest approach. What's the closest approach? The first step, you find RAB small is equal to RAB big plus VAB T. Yeah. RAB is the position of A with respect to B. RAB is RA minus RB. What's A? 3. So 3i minus RB. 5i minus 5j. Remember to the minus outside. This is RAB. Plus VAB will be VA minus VB, so what's VA? 5. Oh, no. On B isn't this. Sorry. B is 2i minus 1j. So 2i minus 1j. Plus VABT. VA is 5i minus 5j. This is VA. Minus VB, صح? VB is this. So minus 8i minus 6j. Close, multiply by t. Simplify. 3i minus 2i is 1i. Minus 1j is plus 1j. Plus 5i minus 8i is minus 3i. Minus 5j minus 6j is plus 1j. Remember, multiplied by t. How do I simplify this? This is how I simplify this. Look, أول شيء, know that this is VAB. Okay, we just found VAB. It's not VABT. This is VAB because you're gonna need it for the second step. Remember, this is step 1. Solve this in the course practice. That's why I'm not really explaining it. This is always step one. That's step two. You do the perpendicular. But for now, let's focus here. How do you simplify this more? You're gonna combine your i's together, okay? And since this one has t, I'm gonna put t in it. So I'm gonna put 1 minus 3, but since it has t, I'm gonna put t beside it. I. Now my j is 1 plus 1. But here, I'm not gonna put just 1 plus 1. It has a t beside it, so I'm gonna put t, j. You can do it like this. For those who are slow or didn't get what I just did, it's completely fine. I'll just show you. Here, you're gonna get, distribute the t, you're gonna get minus 3t I plus 1 t j. And here you have 1i plus 1j. Now you want to simplify. 1i minus 3ti. I can factor the I out, so I'm gonna get 1 minus 3t I. Factor it out. Then 1j and 1tj. I can factor out the j, so it's gonna be 1 plus 1t j. That's basically what I did in the last step, but I just skipped it a bit. So you get this. This is RAB. Step 2. What's always step 2? You say that RAB is perpendicular to VAB. What does this mean? That RAB times VAB is equal to 0. Okay. RAB. What is it? We just found 1 minus 3t I plus 1 plus 1t j times VAB, which is this. This is why I told you need it later. Minus 3i plus 1j is equal to 0. We're multiplying them. صح? Multiplication. Remember, when they're perpendicular, their product is always 0. طيب. What does their product is always 0 mean? That means this times this plus this times this is equal to 0. Remember, when you multiply vectors, you add up, so you multiply the x components added to the product of the y components. 1 minus 3t, so you're going to take the x components, and my I, so I'm going to multiply them by each other. 1 minus 3t times minus 3. Plus, you always add. Now the y components, the j components with each other. 1 plus 1t times 1. 1 plus 1t times 1. What is this equal to when you add it? It's supposed to be 0. 1 times minus 3 minus 3. Minus 3 times minus 3 plus 9. 1 plus times 1, 1. 1 times 1, 1t. 0. Minus 3 plus 1 minus 2 plus 10t is equal to 0. You're going to get t is equal to 2 divided by 10, 1 over 0 0.2. And obviously, what's our unit of time? Hours, right? They're saying what time are the ships closest to each other. They just ask me what's the time equal to. No. If it started at 12 p.m., we took them 0.2 hours. How many minutes is 0.2 hours? 0.2 times 60 is equal to 12 minutes. So after 12 minutes, so what's 12 p.m. plus 12 minutes? So at 12 p.m. Okay? Let's see. شوف كل هالسولوشن. Don't do all of this. So much. والله على الفاضي. والله don't do all of this. 12 p.m. Okay? Really, you can do just this. Closest approach, guys. Okay, هلا chapter 3. I think it's 5 pages, right? 1, 2, 3, 4, 5, 6. Okay. I think we can get them done in a good half hour. بسرعة I can do them, I think. Okay. The weight of an apple is 1 Newton on Earth. Do you expect it to be the same on the moon? No, because J is different. Because the G is different. The weight depends on the G. Since the gravitational field strength on the moon is different, so the weight of the apple is different. Good question, guys. A spring of natural length L is deformed by 3 forces, F1, 2, and 3. Compare the magnitudes of the forces. Okay, F1, the new length is 0.9 L. F2, 1.1 L. F3 is 1.2 L. So, Akid, which one caused the most deformation? Akid, F3. So, which one is the strongest force? Akid, F3. So, F3 is stronger than F2, stronger than F1. F1 is equal to F2. Why? They're using. Okay. Okay. Okay, that makes sense. Yeah, I guess. Look, in the book they give you this formula. Okay, and we never use. This is Hooke's law. Okay, with springs. And I guess, yeah, they're expecting you to use it. But I thought it was kind of common sense. But see, don't be like me, guys. Actually use your brain. And I thought I know it, but I don't know it. Anyway, so I have to apply F equals K delta X. So here F is equal to K, I don't know. It's called K. Delta X, its original length is obviously L, right? The initial natural length is L. When you say delta X, its final length minus initial length. And initial length is always just L. What's the final length? 0.9. So 0.9 L minus initial length L. And you get I don't know. You can get negative 0.1 K. But obviously, guys, it can't be negative, so it's going to be 0.1 K. Okay? Actually, it was minus Kx. The formula was minus Kx. So this would actually become positive. Anyway, that's not my point. So you get this. This is for F1. F2, again, minus K, 1.1 L minus the initial length L. 1.1 L minus L, you get minus 0.1 L, but أكيد this has to be positive, so it's going to be 0.1 L. F3 minus K, 1.2 L minus L, the initial length. So it's going to be, here you're just going to get 0.2 L. So this one's stronger than this and this, but these two are equal to each other. Okay, this could easily come in the exam a lot. Good, I paid attention to this. What are the two types of forces? Contact and non-contact. أكيد. Okay. And the non-contact forces are called, these are all the names, okay? Long range, forces at a distance, field forces. What are the properties of any force? أكيد, the point of application, the direction, and the magnitude. These three you must know them, okay? Okay. Draw the FBD of a sledge moving down a very smooth inclined slope. And the cone incline, we don't care. Let's say this is the sledge. What's the FBD gonna look like? Always, I tell you guys, draw the normal y-axis, sorry. Then draw the x-axis. Okay? The y-axis and the x-axis. Always draw them. Then, with the inclined plane, the first thing I tell you to draw after the y and x is the weight. Just take it down. Okay? And then the normal. Then I really, I hate keeping it like this, okay? I draw the angle alpha, then I go and I rotate everything. Okay? Y هيك X هيك حط هيك W مرتبة. Okay, حط angle هون alpha or whatever theta you want to call it because it's inclined, and you have your normal here. And always if I have a force that has an angle, I split it up into its components, and you have to do this. Okay, بعدين vector symbols. Okay, let's see. This is how they did it. Okay, yeah, I guess if you want to do this is obviously correct. If you want to do this is correct, of course. But why am I doing all this? Because أول شيء it doesn't take me anything. It takes me, what, 2 extra steps? Drawing 2 extra lines? That's barely anything. But it's because I want you to know how to draw FPDs for the next questions later. Know how to do it in detail, because in the next questions, you actually know what you're doing. You know how to draw the FPDs properly so you can solve. Two forces of magnitude 20 and 50 at an angle of 37 are shown. Show the sum of these forces of the diagram. Okay, what do you mean show the sum of these forces? Ah, yeah, if you're adding two vectors, okay, it's gonna be like this, the parallelogram method. Remember, guys, when you have two vectors, how do you find the sum? You extend it as a parallelogram, صح? This is the parallelogram method, and you just connect the diagonal. Okay, calculate the magnitude of the sum. Oh, you have to resolve it into components. أكيد, صح? This one here, let's call this F1. Let's call this one here F2. F1 x is equal to 20 newtons because it's going to the right. F1y is equal to 0 because it's on the horizontal. F2x is equal to 50 cosine 37. At this point, خلاص, you guys know x is for cosine, y is for sine, if the angle is with the horizontal. In this case, it is, right? And then F2y is equal to 50 sine 37. Then you do the calculation. I'm going to show you the solution. Okay, fx is going to be, the total fx is obviously going to be f1x plus f2x, so 20 plus 50 cosine 37. The total fy will be f1y plus f2y, so 50 sine 37 plus 0. Okay, and then the magnitude radical fx squared, you're going to get 67. Okay, the diagram below is the first page, though. Yeah. The diagram below shows two forces, 1 and 2, of magnitude 4 and 15. Find the magnitude of the result and indicate its direction. Okay, I'm just going to show you the solution. What's this? It's so easy. Okay, F1 they said is for هيدي 50. إذا هيدي 53 degrees يعني هيدي هون 37 degrees. وهيدي obviously يعني you don't really need to resolve it into components. It's kind of obvious. F1x is going to be equal, since it's going to the left, minus 4 newtons. But F1y will be equal to 0 because it's on the horizontal. F2x is going to be equal to, it's 15, but the angle I have is with the vertical. Or no, actually no, I have the angle with the horizontal. Why did I find this أنا؟ شو بستهبل أنا؟ I don't need this. 15, the x component I just do 15 cosine 53. And then for the y component I just do 15 sine 53. And then f1x plus f2x is negative, huh? And then f1y plus f2y radical fx squared y fy squared. Okay. Okay, 15 cosine 53, 15 sine 53. Okay, blah blah blah. Okay, Shtanara, yeah. Did they say direction? Yeah, direction. When they say indicates direction, they want the angle theta. So basically, you take theta is equal always shift tan fy over fx. Okay, in this case, they found the fy to be 12, and they found fx to be 5. Just do calculations, ما نخلي. The result is 13. So to find the direction, it's just shift tan y over x. So 12 divided by 5, shift tan, get 67. 7, consider the following three forces. What's the magnitude of the x component of the net force? Okay, this is nice. You have negative 5 here. You have 6 cosine 53 here. And you have 12 cosines 37 here. If you add them, I have 53, huh? If you add them, minus 5 plus 6 cosine 53 is 12 cosine 37. Yeah, you're gonna get 8.2. Okay, what is the difference between inertial and non-inertial frames of reference? Inertial means it's not accelerating with respect to Earth, and non-inertial means it is accelerating. So an inertial frame of reference is that it's not accelerating with respect to Earth. A non-inertial is accelerating. And an inertial frame of reference could be a room of a building. It's not accelerating with respect to Earth. But non-inertial would be a decelerating car because it falls under a certain acceleration. 9. A particle of weight 10 is sliding at a constant speed down inclined plane. Calculate the friction. Find the magnitude of the normal. Calculate the magnitude of the reaction by the surface on the particle and identify its direction. Okay, look. I gave you a rule for inclined plane at a constant speed always. This is a rule. Friction is equal to the force sine theta, and normal is equal to the force cosine theta. So in this case, I'm not going to draw everything now because we have many questions you're going to see where I'm going to draw FPDs and explain why. And I explained why in the course of practice quiz if you watched it. Okay, I explained how I got this rule. So anyway, F sine theta always for friction at a constant speed if it's inclined plane. What's the force? 10. So 10 sine 25 is friction. See, they drew it for you. They said it's what's sliding at a constant speed down. Yeah, okay. So look, you have to do, okay. You know what? I'm actually going to use the FPD. I just didn't want to draw it. If it's sliding down on this direction, okay, it's saying constant speed. I will see for friction, you know, it's a horizontal force. So sigma of x, did we say accelerating? No, we said constant speed, so 0. What's Fx? There's nothing except friction. It's equal. No, wait, no, exactly. See, there is another horizontal force. This W is composed of Wy and Wx. When we say it equals 0, that means what's on this direction equals what's on this direction. So Wx is equal to friction. So mg sine of, they said 25 degrees, 25 is equal to friction. And mg is just the weight. So 10, I think they said the weight also is 10. Yeah, 10. 10. Or I don't have to write mg. I could just write, I could have just written w sine 25. 10 sine 25 is equal to friction. Okay? Again, in the written, this won't slide. Just writing this won't slide. You have to draw FPD. But because I'm going to do many questions like this later, I'm not going to draw. Find the magnitude of the normal. نفس الشيء. But normal, is it horizontal or vertical? Vertical. So we do sigma Fy equals. When you do sigma Fy equals 0, you're going to get the normal is equal to Wy. And Wy is just W cosine alpha. Okay? So you get this W cosine 25. So 10 cosine 25, 9.06. Okay. What are they saying part C? Calculate the magnitude of the reaction and identify its direction. I think huh? Uh I think when they say reaction by the surface, you have two reactions by the surface. Actually, the reaction to the weight is what we call the normal reaction, normal push. And the reaction to the motion is the friction. So when we say that the magnitude of the reaction, that means we want radical n squared plus f squared. So you just take the answer from part A and B, find the square. And they also said direction. Whenever you're finding a net force direction, that means they're asking for the angle. And to do the angle, shift tan y over x. So shift tan n over f. Obviously, the vertical, the y force is the normal. Obviously, the x force is the friction. And this is pretty obvious. Question 10. We solved a question like this in the quiz. 3 identical springs of spring constant K are all attached in parallel to a box of mass m. The box remains equilibrium. Acceleration of free fall is g. What's the expression for the extension of each spring? Okay. أول شيء, let's kind of like let's draw the FPD. You know, I want to draw the FPD. I'm gonna say this mass m. I'm gonna put it as 1 point here. أكيد it has its weight mg. صح. Okay. What's putting it up? Tension. How many? 3. Because they're all the same identical spring. So this is T, T, T. How could you write this? You could say T total in your written equal to T1 plus T2 plus T3. And then you could put a side note like here as identical springs. طيب. So it's being pulled up with 3T. طيب. Is it bouncing up and down? No. So sigma Fy is equal to 0. So mg is equal to 3T. What is T? It's a spring. So F is equal to Kx. So the force is equal to Kx, right? So mg is equal to 3 times the spring constant x, or actually minus kx. But we don't care about the minus right now. Okay. Into how do you find? They want the extension. Give it tail extension. Take everything to the other side. So x is equal to mg over 3k. I think that should just be the answer. Yeah, mg over 3k. A car of mass 800 can decelerate from 20 to 0 in 4 seconds. Calculate the force. Force is equal to mass times acceleration. Mass is 800. Acceleration, how much? 20 to 0 in 4 seconds. So delta V is 20 minus 20 over 4, which is minus 5. So the acceleration, acceleration is equal to delta V over T. So minus 20 divided by 4, which is minus 5. So mass times acceleration, so 800 times minus 5, I minus 4,000. But I think they just keep it as 4,000. Oh, they kept, yeah, okay. Basically, don't try and be fancy. It's negative 4,000. Okay, you get negative 4,000, put as negative unless they say magnitude. Define inertia and relate it to the mass. Inertia is the tendency to continue your state of motion. Yeah, unless a force causes it to speed up or slow down. The how do you relate inertia to mass? The quantitative measure of inertia is called mass, right? The trolley in figure below accelerates at 2 meters per second squared when the weight of the hanging mass is 4 Newton. Calculate the inertial mass of the trolley. What is the gravitational mass of the trolley? طيب, F is equal to ma. The force is 4. The acceleration is 2. So m times 2. So m is equal to 2 kg. What's the gravitational mass of the trolley? كيف يعني inertial mass gravity? Huh? I think they're just the same thing. What is the difference? Difference between gravitational mass and yeah, see. Um. Ah. Okay, basically, Hebel, they're the same thing. Okay, they're the same value. Okay, so they're both 2 kg. Question 14. Okay, I guess we're making progress. We have 2 pages left. A person walking at a speed of 0.9 applies a force of 500. What's the magnitude of the force exerted by the ground on this person? أكيد action reaction force, so should just be 500. Yes. A rocket is propelled by hot gases pushed out of it. The graph below shows how the force by the gases varies with time. Plot the variation of the force exerted by the rocket on the gas with time. What? Okay, yeah. It should be the same thing. Yeah. So, how does a rocket go up? It's the action reaction force. It uses Newton's third law that it pushes gases out, so the gas will push back up on the rocket with the same amount of force. So, this is the force, the this is the force of the gases on the rocket, right? So this is the gases pushing back up on the rocket. So how would be the forces of the rocket pushing on the gas? The same exact thing. Action reaction. Newton's third law. Oh. I think I think why it's upside down is because action and reaction are opposite in direction. فإذا هاي نازلة لتحت أكيد the other one will be going up, but they're still gonna plateau. يعني they're still gonna become constant at the same point. Okay. Diagram below shows the direction of F1, and that a particle shows the direction of the force that a particle 2 exerts on particle 1. Draw the reaction of this force. I think it's just like this. I'm not sure. Okay, yeah. Just the opposite of this. What's the opposite of this? This it has to be the same length of the arrow, huh? I drew it wrong. 3 wooden boxes are placed on identical wooden floors and are pulled with horizontal constant forces F1, 2, and 3. All 3 boxes remain on rest. The friction forces on each box are F1, 2, and 3. Calculate the magnitude of the friction forces. أكيد F2 will have the highest one. What? So, apparently F1 is the highest, F3 is the second, and F2 is the weakest. Which I don't really get why. Because friction is equal to mu n. And the more the weight is, that means the more the n is. So I don't know why this is correct. I guess what they're trying to say is the more force you apply, the more friction you have. But if someone can correct me in the comments, that would be great. Thank you. But for now, just memorize the more force you put, the more friction. Which makes sense, but come on, what I said also makes sense. Into what form of energy does friction convert the energy of motion? It should be thermal. Yeah. 2 blocks are connected by a string, S2, as shown below, and the upper block is pulled upward by another string, S1. The masses of the upper and lower blocks are respectively M1 is 200, M2 is 400. String S2 between the blocks will break if the tension exceeds 5, and string S1 will break if its tension exceeds 10. Okay, calculate the tensions in string S1 and S2 when the blocks are in equilibrium. Determine the largest acceleration the system can be given without either rope. Oh no, without either rope break. Type. We're gonna draw here FBDs. Okay, these ones are very easy because we're just working with vertical force. Let's start with M2. I'm gonna put M2 over here. M2 has its mass for 100 grams and G is 10. So let's draw its weight. How much is its weight? 0.4 kilograms times 10 mg 4. So 4 newtons. It's gonna be pulled up with a tension. It's called tension 2 because it's S2. Type x-axis, y-axis, vector symbol. Second one here, this is block 1. It's called here block 2. You now have S2 pulling M1 down. And let's call S2 let's call it T2. So we're gonna draw over here, it's being pulled down by T2. And it's also being pulled down by what? By the weight. It's called weight 1, right? Because it's object 1. Was being pulled up now, all of this by what? String 1. So it's called T1. Vector symbols, I should have put in x-axis. Okay. Let's see. They're in equilibrium. So that means sigma fx is 0, sigma fy is 0. Sigma fx is 0. There's no horizontal force. I'm just going to skip. Sigma fy is equal to 0. Yani 4n is equal to T2. Okay? T2 is equal to 4. Here, sigma fy is equal to 0. So T2 plus W1 is equal to T1. So 4 plus W1, how much is the weight of object 1? Object 1 is 200 grams, so 0.2 kg. How much is G? 10, so 0.2 times 10 is 2. So 2. So equal to T1. So T1 equals 6 Newton. طيب. We have T2 is 4, T1 is 6. I think that's what they want. Calculate tension string S1. S1 would be 6 newtons, S2 would be 4 newtons. Let's see. Yeah. T2 is 4, 4.0. T they meant T1 here. 6.0. Okay. Determine the largest acceleration the system can be given without either rope breaking. Let's see. Okay. Now, since we're saying it's accelerating, we بدنا نضب all of this. Okay. Let's say it's accelerating. Okay. Accelerating, خلينا نقول it's going downwards, right? Let's say it's going down. نفس الشيء. You have the weight here. You have sigma T. You have T2 pulling it up. So now sigma Fy, since we're accelerating, is gonna be M. We're talking about mass of object 2, or is this object 2 or object 1? Object 1. Mass of 1 is point. No. I did 2 or 1? No. Yeah, I'm using this one, so it's 2. Talking about this one here. So 0.4 A is equal to sigma Fy. What's sigma Fy? Let's say it's accelerating down, so 4 newtons obviously greater than T2. I always write 4 minus T2. Okay. Then here, sigma Fy now is going to be equal to MA because we're accelerating. What are my vertical forces? I have T1 up here, T2, W1. So let's say it's accelerating down. So W1 plus T2 minus T1 is equal to the mass here is 0.2 A. 0.2 because mass 1 is 0.2. This one is here mass 1. This is mass 2. طيب. Let's do some system of equations here. You're gonna get here. We want to solve for A. I guess we want to solve for A. A is gonna be equal to 4 minus T2 over 0.4. I don't like having decimals. 4 divided by 0.4 is just gonna be should be 10. Yeah. And then minus 2 is gonna be minus 4 T2. Yeah. Divided by 1 over 4. As no 1 4 over 10. 10 over 2.5, no? 2.5 T2, sorry. 1 divided by 0.4. طيب. Here, what is A equal to? A is equal to W1 plus T2 minus T1 over 0.2. We can simplify here. يعني بسرعة we can put W1 as what? M1G, right? Mass 1 0.2. G is 10. So the weight W1 is equal to 2. So here W1 I'm going to put 2. plus T2 minus T1 over 0.2. Again, make your life easy. 2 divided by 0.2 is 10. T2 over 1 over 0.2 is 5. And minus 5 T1 equals to A. Right now we took A, we took this to the side, whatever. So that means these are equal to each other. So 10 plus, oh my god. Actually, you know what? No, don't equate them to each other. We know what T1 and T2 are because they said S2 T2 is 5, S1 is 10. We're looking at the maximum, the largest acceleration. Just substitute these values. So T2 is 5. So let's go here. 10 minus 2.5 times 5. You're going to get minus 2.5. And let me see, is this correct? Oh, ding. Oh. Okay, T2. Okay. Okay, and I got all of this. كيف هاي? Wait, no. T1. كيف isn't it going down? Okay. Let me solve this again. Okay, so there are two things. I'm sorry, I wasn't paying attention, but there are two things I found that I did wrong here. أول شيء ال LPDs are all correct عادي يعني. But I didn't read it's pulled up. So يعني the one up is greater than the one down. So هيدي أول غلطة. تاني غلطة, second mistake, is that I started solving from the start. It's good to keep your answers in letters until you get your final step. Here, we said accelerating, so it equals MA, صح? Let's call this M2A. Sigma Fy, what are my vertical forces? T2 and 4. It's going up, so T2 is greater than, let's call this the weight. Okay, let's call this the weight. Or MG. I'm just gonna call it M2G. Okay? Is equal to M2A. On Sigma Fy is equal, again, M1A هلا. This is going up. T1 is greater than T2 and W. So T1 minus T2 minus W1 is equal to M1A. طيب. Again, هلا we need to find acceleration. So we're going to do what I was doing in the last question. And you have to take M2 to the other side. So T2 minus M2G over M2. Here, T1 minus T2 minus W1 over M1. This is equal to this. طيب. So T2 minus M2G over M2 is equal to T1 minus T2 minus W1 over M1. I'm gonna remove W1, حط MG1, M1G. Okay. Here you can continue to simplify. I'd cross multiply in this case. M1 times T2. So I'm gonna get M1 T2 minus M2G. I won't distribute it because M2 T1 minus T2 minus M1G. You get this. Listen. Cut me some slack. Well, it's 12:15. I'm on like 6 hours of sleep. Listen, I simplified wrong. Wallah, just the simplification part. Wallah, this question is so easy. Just the simplification part's kinda annoying. Wallah. Look. Basically, you got these two equations, okay? Until now, عادي. I'm gonna use red because I don't like black. Not like that, guys. Not like that. It's like I just don't like the color black when writing. Uh, you have this equation here. We have and why did I do all this? Let me actually use the top one. It's better. You have these two equations, okay? You can substitute T2 with M2G plus M2A. Look, T2 can be equal, take this to the other side, M2A plus M2G. Okay? So here, I can go and substitute this with this. So it's going to be T1 minus T2, which is M2A plus M2G, minus W1 equals M1A. Type. See here, distribute the minus, right? So it's going to be T1 minus M2A minus M2G. W1 is MG, M1G, right? How was W? W is equal to MG. So minus M1G equals M1A. Type. To make our lives easier, we're going to take the M1s together and the M2s together. Okay? Sorry, no. We're going to take the A's together and the G's together. Why am I doing this? Because I want to find A. Okay, so I have to take the A's together and the G's together. Okay? So I'm going to take this A over here and we're gonna continue. So it's going to be T1 minus, we're going to take this to the other side. So minus M2G minus M1G is equal to M1A plus M2A. Okay, here we can do some math. T1, take G out. Minus G out, huh? Minus G out is going to become M2 plus M1 is equal. Take A out. It's going to be M1 plus M2. M2 plus M1, M1 plus M2 in the same thing. Now can I solve for A? Yes, I can. A is just going to be equal to T1 minus G. I'm going to say M1 plus M2 instead. It's cleaner. M1 plus M2 over M1 plus M2. I just divided by M1 plus M2 on both sides. You're going to get this is your acceleration. Okay? Took me a good half an hour to find out why. Okay. Now can I just substitute? Of course I can. How can I find acceleration? T1. What's T1? 10. So 10 minus G is obviously 10 into M1 plus M2. 0.2 plus 0.4 because they're in grams, yeah? 200 grams, 400 grams. See 0.2 plus 0.4 over M1 plus M2, again 0.2 plus 0.4. So you take calculator, you put 10 minus 10 into 0.2 plus 0.4 over 0.2 plus 0.4, and you get 6.67. Yes, okay. Okay, so we found the largest acceleration. Explain top 20, and okay, we'll do this. These are questions I doubt come, but yeah, we'll do it. Explain with reference to forces when an object moves rectilinearly at constant speed. What? With reference to forces? Okay, when something moves at a constant speed, the net force on it is 0, right? So let me see the solution. Check to see. Tell me my answer is wrong. Stop. No, man. Don't do this to me, no. I thought 6.7 خلاص we're friends, man. What is this? What's all this? Check to see if this acceleration does not bring the log string. T2 is M2A plus M2G. Okay. 0.4. So it will break. So the log string not to break. The energy of the system should be equal to T2 max minus. I'm gonna cry, man. It's 12:30. Just let me sleep. Oh my god. The lowest for the lower. What am I reading? What? Okay, minus 2G on the other side divided by. Okay, 1 second. Let me read this. I got. Bro, I swear to God. Wait. I swear to God, I got 2.5 first. Wallah, I remember getting 2.5. I remember getting 2.5. Listen, I don't know. Honestly, I'm not bothered. I'm gonna find out after I finish recording. I'll go back and watch the recording. But I remember getting 2.5. Okay, so basically, what happened here is we got our acceleration to be 6.67. So you have to check if 6.67 will break the string. We know, okay, we got T2 is 5 newtons. Or actually, no, it's given in the question. T2, the maximum of it. Oh, this is not the question. They told us, sorry, T2 is 5 and T1 is 10. So since T2 is 5, we have to substitute our acceleration in it. In the equation we got over here, we got this, right? So T2 is equal to M2A plus M2G. Substitute M2 and A and G, and you have to check the tension, the force. What do you get? You get 6.67 newtons, okay? But the maximum is 5, so wouldn't that break the string? Yes, so that means we can't use the acceleration we just substituted right now. We can't use it, okay? طيب. For the lower string not to break, the acceleration of the system should be 1. Again, what they did is just they rearranged this equation like I did the first time we saw it. Okay. For it not to break, acceleration should just be just take M2G to the other side and then divide. So you're gonna get A is equal to subtract by M2G divide by M2 and substitute. T2 max we said it's what 5. M2 we said 0.4, G is 10, M2 0.4. You get 2.5. The answer we got. Now this is your second max acceleration. Again, you have to check it. Obviously, it's gonna work on string 1. Check string 2. Okay. String 2. What was the equation we got for string 2? You get this. T1. We need to make sure it doesn't break T1, so let's move everything to the other side and see how much T1 would be. We're gonna get T1 is equal to M1A plus M1G plus T2. So you have this expression now for T1. Substitute the acceleration we just found, the G كل substitute it in. 1 second. And you're gonna get 7.5 newtons. But we know that the max for T1 is 10. So is 7.5 more than the max? No. So will it break? No. So since it won't break both, that means 2.5 is the max. Which is the answer I got the first time. By the way, just letting you guys know. Stupid question. I doubt they'll bring it. Calculate. Okay. Explain the difference. What happened? Why would the force? What the object may put on constant velocity? When you only have constant velocity, when there's zero net force. Okay. A cyclist is pedaling along a level road. And then free wheels, and moves without touching pedals down a hill inclined at 15 degrees without down. The graph shows the speed. Determine the acceleration at t equals 18 seconds. Okay. Again, at t equals 18 seconds, the acceleration would just be the slope of this because it's velocity with respect to time, acceleration velocity of time, divided by time. But let's take the slope of this. Here we have 14, 15 is over here. This is 15, comma 4. So 15, comma 4. So 15 seconds, 4 meters per second. هون عندك let's take this point. This is actually a good one. How many blanks is this? 1, 2, 3, 4, 5. 5 blanks. So it's gonna be this is on the what's third blank? 1, 2, 3. Yeah, third blank. So it's gonna be 7.6. So 7 point as the 18 seconds, 7.6 meter per second. Okay, slope y2 minus y1 x2 over x1. 7.6 minus 4, so 3.6 over 18 minus 15, 3. So it's 1.2 a meter per second squared. Okay. Explain whether the network from t equals 0 to t equals 20 is positive or not. Okay, we did not take work. But it should be positive, right? What, phi BII? I didn't see this. Determine the total displacement from t equals 0 to t equals. This is, honestly, listen, my opinion, this is something that would come in your final. Okay? But look, let's see. From t equals 0 to t equals 20, you have to find the area, kid. So the area here is 15 times 4, length times width, 60. And the area here is a trapezoid. The bases are 4 and 10. Oh, this isn't. here it ends here at 20, yeah, are 4 and 10. So base 1 plus, remember trapezoid, base 1 plus base 2 over 2 times the height, which is from 20 to 15, 5. Okay, so 7 times 5, so you get 35. So 60 and 35, you get 95. I just calculate the area, it's not rocket science. Well, okay, the change in the kinetic energy is positive as the final speed is greater, based on the, yeah, I'm telling you, an idea, but it's not required. Work energy theorem وعلينا we take them in term 2. But still, it makes sense. Obviously, the change in the kinetic energy is positive because the final speed is greater than initial speed. So, okay, the network will be positive. It makes sense. Okay. Yeah, the work energy theorem is something to do. Kind of, we're gonna take it soon. I forgot. We took it last year, but I forgot. Okay. IV. The weight of the cyclist and his bike is 800. As the cyclist descends down the slope, calculate the normal reaction of the cyclist, resistance force on the cyclist. Okay, so I'm gonna put it like this. في friction شيء okay, no coefficient of friction, but I guess there's gonna be, the speed is increasing, so it's accelerating. So you can find, I guess. Okay, let's see. I'm gonna state that the acceleration is equal to 1.2, right? Because we found that in part one of the parts. Okay, we have the inclined plane. This is how I always like to think about it. He's going down, right? Right. Find the normal reaction, find the resistance. أول شيء told us that the inclination is 15 degrees. Okay? دايما all these questions FBD صح؟ أول شيء بلش بال y axis x axis. بعدين تاخد الويت والnormal force. هلا what do? We draw it again. I'd like to rotate it. Listen, I'm like this. Many students tell me, why are you rotating? You're wasting your time. What is this FED, bro? Who draws it like this? يا أخي man, حل عني. من الآخر, I don't care والله. But this is the way I find easiest for me. وأنا I feel like if you weren't taught this way, this would be easier for you as well. W on 15 degrees. Okay. Here you have the normal reaction, and the direction of the acceleration is to the right. Since they said there's a resistance force, we're just gonna say that there's some friction over here. Okay. طيب. Even though they didn't mention any friction, but you have to find it. Okay, and obviously we have W, we're gonna resolve it into WX and WY. طيب. This is up here is the normal, of course. Let's see. We're accelerating. Sigma Fy is equal to what? 0. Why 0? Are we jumping up and down? No. So يعني N is equal to Wy. And what's Wy? It's W cosine 15. Okay. So weight 800 cosine 15. Whatever that is. So we found the normal reaction. 800 cosine 15. Sigma Fx, now we're accelerating. So mass times acceleration. See here, we need the mass. Okay. We have the weight. We know W is equal to mg. And I'm pretty sure they said that g is 10. Oh no, they use 9.8. Okay. So I can find the mass. I can just divide the W divided by g. So 800 equal to the mass times 9.8. So 800 divided by 9.8. I'm just gonna find it from now. 81.6. Let's just say 81.6. That's the mass. Okay. طيب. The mass is 81.6. The acceleration is 1.2. What is my x forces? We're accelerating to the right. So Wx should be stronger than F. So Wx minus F is equal to the mass, 81.6, times the acceleration, which is, we found 1.2. Wx is W sine 15. So 800 sine 15 minus F is equal to 81.6 times 1.2. So to find the resistance force, basically the friction, can we just find it? Of course we can. We can just solve this equation. So you're going to get 800 sine 15. Okay, you're going to get this answer. And obviously, we're going to take the F to the, we're going to take the F to the right to become positive and this to the left to become negative. So I'm going to subtract by 81.6 times 1.2. So subtracted by 81.6 times 1.2. You get 109. So friction is 109 newtons. There you go. And this one was 800 cosine 15. I never solved it. I just put 800 cosine 15. Okay. 773. Okay, we're done. Thank you so much for watching, and good luck.